Nuclear and particle physics. Now, it's only been just over 100 years, and a property of some atoms called radioactivity was discovered, and it's been about just a little bit over 100 years since the discovery. Now, this random girl scientist called Marie Curie got deeply curious, and she wanted to understand about it and why it happens and everything. And so, Curie and other physicists actually worked on this idea, and stupidly enough, because of their stupid amount of effort, they found that there are more to atoms than everyone actually suspected. In fact, some of the particles that made up the atoms, this woman herself discovered, is indeed what happens to the universe. Like, made up particles that made up atoms, and indeed the universe. Those particles also made the universe. And so the studies of these atoms and particles, actually how they interact with each other, are known as the nuclear and particle physics. So let's get this started with. Now, inside atoms, of course, atoms basics, they're made of protons, neutrons, and electrons. Now, a regular anisotropic atom would be an atom with the same amount of protons and electrons. And an ion basically be an atom with an unequal amount of protons and electrons. If there's more protons than electrons, it has a positive charge. If it has more electrons than protons, then it has a negative charge. Because opposites attract, people. Now, there are battles against forces. Like, you've probably ever heard of repelling. It's when magnetism is against each other. And in the everyday world, the electromagnetic force actually makes things that are the same repel each other. Now, there's the other force called the strong nuclear force that is much more stronger than the nuclear force. And like if you try to put a north end of a magnet with another north end of a magnet, it will try to repel each other. It's really hard to put them together at the same angle, like wonk, wonk, wonk. Yeah. But the nuclear force is basically like a glue. Like, let's say you put super strong glue here and permanent glue here, and then just for a fraction of a second, you get these two together, and because of the glue, they can't separate each other. Unfortunately, it means they're stuck together at the same time. They'll stick forever. The protons, unless the protons are like the repelling force is stronger than the holding bond of the glue, which it is not, then that will probably be a weak nuclear force. But in this case, it's a strong nuclear force because it stays there permanently until the magnetism wears off, that is. Now, you can break into a nucleus. You can technically break protons into neutrons and electrons, of course. And this also creates a substance like the radiation that we talked about. And that is terrible. And if I'm just going to go a Spider-Man quote here, with great power comes great responsibility. Nuclear fission is a way you can actually create great renewable energy. However, the fact is, there's a downside to it. You create lots of nuclear waste, and it can also be used to make bombs, which was used in World War II, and could destroy all of Korea and parts of China that actually that have some territory linked with Korea in just a few seconds. If you had enough A-bombs, that is. In fact, the Chernobyl in Ukraine accident, that actually went into a meltdown, and that place is still unvisitable. Well, it is less dangerous, but it's still unsafe to this day. Of course, that's why lots of people hate nuclear energy. But it also has less casualties than coal mining and oil and all that stuff, so I guess it's still better than coal, I guess. Also, it has more dangerous waste. Nice. And so, is radiation actually helpful or dangerous? Now, no one actually knows. Now, what is radiation anyway? It's like when there's an unequal amount of neutrons and protons, like let's say protons are more than neutrons, then one proton turns a neutron and it emits a positive amount of energy, like a positive version of the electron. However, if there are more neutrons than protons, one of the neutrons turns into a proton and it also emits an electron. And those emission of electrons and positrons, as they're called, is basically what's radiation. And it's really harmful because it can kill us. Is radiation helpful or is it dangerous? Radiation can be used like X-rays to see us. X-ray is a type of radiation, and doctors use small amounts of it to actually see what's happening inside of us, and you can even use it to kill cancer. However, too much exposure can kill you, and the A-bomb is a radioactive bomb and it kind of killed a lot of people. And there's even loads of different types of particles that actually make up these protons, neutrons themselves. I'm not going to say them all because that'll take too long. Now, the graviton is a theoretical thing, but I don't think it exists because if it does, I've seen the map. I don't understand it at all, but I can already see that there's something wrong with it. The one without gravitons and the one with gravitons. According to the people who explained it to me, the ones without the math calculation without the graviton made sense. Well, if you try to put in the graviton, it will just wonk up the math. And I just started trigonometry and I didn't even start calculus yet, so I don't think I'll understand this for a long time. And that's basically where I'm just gonna end this here. Subatomic interactions are always here. Of course, that's what makes up these protons and neutrons to create those electrons. However, people even try to create the Higgs boson too, and it does exist. People have said it does exist, but it's still only a theory. And fusion itself actually happens inside the sun. We can use it to actually go ahead and create renewable energy. But right now, more energy is needed to create, like, the output energy is less than the input energy. So we're going to need to find some new ways to do this. And I'll see you guys soon in the next chapter. Quantum mechanics. Yay! Time for qubits! See you guys soon. Bye.